basically, this talk is going to kind of cover our journey to provide a centralized admin experience for our microservices architecture. So what are we going to be covering today? We're going to first start talking about a little bit about what we were trying to build, then who we were building it for, and finally, how we built it. So what exactly were we trying to build here? Well, to provide some context on who we are, and I promise this is the only corporate slide I put in here. I just want to use this to make sure you understand why we're dealing with this problem and why we need to solve it. So Broadleaf Commerce, over the years, we work with a wide variety of companies to help them build e-commerce sites. One of the areas that we've always been experienced in are building metadata-driven admins. It's always been an important thing for us to let developers focus on application code and not on, building out admin screens. So we started all way back with Adobe Flex, GWT, a timely implementation, and now our latest iteration today. And what led us to this iteration is that we've been working with a lot of our users to better support a microservices architecture. Traditionally, we've been in a monolith, and so you have everything in one place. It's easy to just serve templates from that, and you're good to go. You got your admin. But now we have things in a lot of different places. And so we wanted to build a system that makes providing a centralized experience easier. So why is this even important, though? Why do we want to provide a central admin experience? Well, you might come up with a number of your own reasons, but for us, we didn't want to have a separate admin application managed for every service as we add it to the mix. And business users don't want to have to log into a bunch of different places in order to do their day-to-day job. So for us, we didn't want to come up with this nice architecture with microservices, a nice clean bounded context, but end users have to log into 4 different websites to do their job. So it was important for us, for our end users, to have that central experience. So really, while we wanted the architectural benefits for microservices, we also wanted a good experience for the people using the software. So who exactly are we building this for then? We are building it for the business users and the developers who support them. So our business users, they don't really care about any of these technical details that I'm going to talk to you about. They don't care about microservices or bounded context or cloud or anything like that. They really just want a single admin interface that works and they can just do their job. So our primary audience is really the developers who are supporting the business users, both on the front end and the back end. Now, for back-end developers, it was important for us that we have a system that allows them to easily contribute new admin interfaces to the centralized admin without having to write any HTML code. A lot of the people we work with don't have a lot of front-end developers, and so we wanted to make that process easy. And we wanted to make it possible for them to integrate existing services and gradually adopt our system. For front-end developers, it was important for us that we still give them a chance to extend and enhance the admin experience as they need to. As much as we want to give back-end developers control, we also know that sometimes people are going to need to customize. So we wanted to provide them some defaults, some building blocks, some components that they can use, but get out of their way when they need to replace what's there. And of course, we wanted to use the modern front-end technologies that everyone's using nowadays, like React and everything else. So overall, really what we wanted to do is we wanted to create a framework that enables developers both on the front end and the back end to provide a centralized admin experience for a distributed microservices architecture. So how exactly did we build this? So the first part of the system that we built is the client application. So this part of the system is responsible for rendering the various screens within the admin. We wanted to build our client application so that it was built for headless APIs within a microservices architecture. We wanted it to be able to integrate with any service we got out there. And we wanted it to be a single-page application that was both fast and responsive. So we ended up with a modern front-end stack with React at its core. The second part of the system we created is what we call the metadata service. This service is responsible for providing dynamic metadata that informs the client application what it needs to render and where to get the data from. So we created this service because, like we said, we wanted the application to be dynamic. And we wanted to give back-end developers more control over what the screens were that manage the data within their services. And so the metadata from the service provides several important functions. It provides view routing for the application. Routes being the relationship between the browser's current location and what view is actually rendered on the screen. And so if a back-end developer is going to be able to add a new admin interface for managing some customer data, then they're going to need to be able to direct the user to that view in their browser. Another thing we provide is the metadata provides API endpoints. And this is basically as it sounds. So if you have a list grid on a page that has maybe some product data, you need to be able to tell that list grid where to get the data from. Pretty simple. And most importantly, we provide component metadata as part of the metadata service. So component metadata is what describes the various views and forms within the admin. So if a back-end developer is going to add a new form for managing some data, they needed to be able to describe the various fields, grids, or other components necessary to do so. So all in all, the way this kind of works is that the client application knows how to render things, and the metadata service tells it what to render and where to get that data from. So now, as a backend developer, I should be able to go to this metadata service when I need to add a new admin interface, add some of this metadata stuff, and suddenly I should be able to have a new screen. But wait a second, what exactly is metadata? What am I even talking about here? What does this even mean, right? It's just a word. So at the end of the day, metadata is simply structured JSON data that describes a component tree. Take all that, stitch it together, and you get a user interface. So one way to kind of think about this is to take some simple UI component like a text field and start listing off the various attributes that text field possesses. So it has a type, it has a label, a name, a placeholder maybe, and so on. And that's really all that metadata is. It's a graphical user interface flattened down into a structured JSON data. And so the metadata service provides the client application this JSON metadata. And the client application then interprets that metadata in order to render the various admin screens, whether it's a product grid or a customer grid or some form or whatnot. So when we first created metadata, we knew in the client application we were going to be receiving some JSON from the metadata service. So we knew it was going to be a JSON. And when we first started, that's literally all it was. And I know what you're thinking right now, that sounds crazy. But we literally had giant nested JSON structures we inserted into a MongoDB and returned through our metadata service to the client application. And it was painful. It was terrible to manage. It's really hard to reuse JSON. And we ended up with problems where you would have typos create these weird runtime errors that didn't make any sense. And also, JSON can be pretty hard to parse and understand. So we knew we needed to make a change. Because as much as JSON might be the end format that we receive on the client, it's not a very friendly format for backend developers to work with. So we needed something better. So that led us to create a Java DSL. So basically, we created a Java syntax for building and representing metadata that allowed us to more easily contribute the metadata without having to deal with the structure like JSON. This also allowed us to add a lot of nice improvements. So we're able to use Spring Auto configuration to partition the metadata we provide into different dependencies, allowing someone to subscribe and pick and choose the metadata they want to use. We were able to create intuitive builder syntax that allowed developers to have a more guided and opinionated approach when they're building this metadata. It just feels a little better. And we were able to get type checking for free because we have Java, so that's a huge improvement already. And we were able to add things like validation, so validating the output of our builders to make sure that when you build this component, it's going to be built correctly. And things like tests, so unit tests, integration tests, all the 9 yards to make sure that the metadata is built consistently and our admin looks as it should. And of course, we were able to add things like internationalization of messages. So now the client application doesn't have to worry about maintaining message bundles because it's just provided through the metadata. So overall, the Java DSL was a way for us to provide a more intuitive, friendly interface for developers when building all this metadata. So one thing that I want to just call to note, on that last screen, I had a little code on there. And that was the Java DSL to build our actual products listed. Just that little bit of Java DSL. And so we were able to describe the various columns as part of that grid, the endpoints to tell it where is the product service, where do I get this data from. But we could easily take that same metadata, we could copy and paste it, change up the columns a little bit, replace the endpoint and point towards a customer service. And now in your admin, you have a grid that's managing customer data. So that's the kind of experience that we want to create. And this is where the power of this system starts to shine. Is that a backend developer, I can go into this metadata service and create some metadata to describe a user interface, okay? And I don't have to worry about HTML here. I can just describe the user interface. The metadata service sends that to the client application, which then interprets it and renders the various screens. So I can do this for a new microservice I just stood up. I could do it for my legacy microservice that we've always had, but we never really had an interface for managing. And so that's what we wanted to create here. This is kind of the goal of the system. All of this without any HTML or front-end code. So you might be thinking now, who needs front-end developers, right? We just replace them. We can just provide metadata. Well, as a half-time, sometimes full-time front-end developer, I'm not too worried because even though we want to support back-end developers and make it easier for them, we also understand that sometimes you're going to need to go in and do something custom, right? Maybe the out-of-box stuff doesn't work for you, right? Maybe you want to create some new, interesting concept. Well, that's where we try to serve the front-end developer. So one of the ways we wanted to provide extensibility is by allowing the dynamic registration of components within the front end. So basically, you could create a React component, you register it with the component registrar, and you give it a key. That key, her name, is now targetable by the metadata service. And so you're able to target in metadata, hey, I want to render this component. And at first, this is kind of what the structure was, roughly. Now, we ran into a problem with this. So as a front-end developer, when I am creating this React component, I need to understand what props am I going to receive? What context am I rendering it in, right? And so I need to understand what is the purpose of this component. And likewise, a back-end developer working in the metadata service, they need to be able to just understand what properties I need to give this component. What metadata is it actually expecting in order to configure itself? So we needed a way to further discriminate these components rather than just by a name or a key. As an example, views and fields are very different. So views in this case are basically a giant form, right? It could be a custom page, it could render some grids, it could render a lot of things, right? It's really a blank slate. And this is a very different thing than a field, like a text field. Like a text field, for instance, has a narrower scope. You need to do things like interact with the form state, you need to deal with validation, and so on. And so what we ended up doing is creating what we call classified metadata. So we created distinct classes of components that created an expectation around the type of context these things are rendered in and what props you should expect when you're registering them. So we have view components that, like I said, they're a blank slate. And they might receive some general props, like they might receive the metadata for the view, they might receive some routing information in case they need to direct the user around. And then we have field components, and these are in a narrower scope. They receive the form context, allowing them to interact with the form state, and they receive the metadata for the field. And we ended up overall with about 4 distinct classifications that fit our users' needs so far. So for these classified components, we provide a component library that has a lot of the basic stuff out of box. Things like text fields, lookups, date fields, all things like that, right? And this should provide building blocks for a lot of people, front end and back end, to target as they need to. But we also wanted to make sure we had these extension patterns in place so someone can easily come in and add new fields or replace the existing ones completely. So now you can come in and a front-end developer can register a new field component and expect a certain props that they will receive as part of that component. So you just create your React component. There's a certain set of props that you should expect to receive, and then you can do whatever you want from there. And these components can be as simple or as complex as you like. We have simple components, like I said, a text input. That's a pretty simple one. You could also do a complex component, like a really interesting widget that interacts with a bunch of microservices to provide some interesting data lookup scenario. So there are a lot of ways that you can create these fields in this isolated context to fit the needs of the business. Sometimes, though, you need a little bit more than a field, right? You don't need something just to render within a form, but you actually need an entirely custom page. And so that's when you would use something like a view component. So you create your component, and you can expect a certain set of props to that component, like the routing information, the metadata for that field, and it's really up to you to what you want to do with it. You can use as much metadata or as little as you like. You could use no metadata and render a static form that manages user preferences. You could use a little bit of metadata to provide API endpoints that will allow you to point a dashboard to different services. Or you can use a bit more and you can provide the form components for a form, such as in this example right here. But you give your own take on the decorations around that. So registering fields, registering views, these provide ways that a front-end developer can customize and add new behavior or replace existing behavior when they need to. So I want to kind of recap what we just kind of covered. So we were trying to create a centralized admin experience for a distributed microservices architecture. We were doing this for the business users and the developers who support them. Overall, we wanted to create a system that allowed people to easily integrate newer existing services so they can gradually adopt our system or easily add new ones in as they become needed. And we achieve this by creating this metadata service that delivers dynamic metadata to the client application in the form of routes, endpoints, and components. This metadata is created using an intuitive Java DSL that gives developers a guided and opinionated approach to let them describe the user interfaces they need. That metadata is then interpreted by the client-side application in order to render the various components within the various screens. Now, back-end developers have the ability to easily integrate newer existing services without having to go into the HTML or even know about React at all. And front-end developers, likewise, they now have the ability to extend and enhance as needed. So overall, what we try to do here is provide a framework that enables developers, both on the front end and the back end, to create a centralized admin experience that meets the needs of the business and the needs of the architecture. So thank you all for coming to hear me speak today. I hope you found something interesting in this talk. Feel free to come by our booth. I believe it's 320 and talk to us more about this. We also have a webinar coming up where we'll go into a little bit more detail and probably do some actual code examples. But other than that,